We're going to perform an experiment similar to one of the experiments that Michael Faraday performed when he was discovering and quantifying electric flux. So he had a pewter pail that was used to hold ice, so that's why this is sometimes referred to as the ice pail experiment. I have this aluminum conducting container here, which will be our pail, and I'm putting it up here on an insulator so it's isolated from ground, and we'll have an electrometer like Michael Faraday did, a gold leaf electrometer. And to remind you that this one has zero charge on it right now. This is the state with zero charge. I have a little bit of a kink in the gold leaf, so that's why it's not exactly at zero here with zero charge on it. Now I also have a PVC rod and a piece of silk so that I can contact the PVC with the silk by rubbing and charge the PVC negatively. And we can see the influence on the electrometer that senses the electric fields emanating from the negatively charged rod. I've positioned the pail next to the electrometer and I've charged the PVC rod. So now I'm going to put the PVC rod inside the pail, and you can see there's a deflection of the electrometer. I pull it out, the deflection goes away. Put it in, there's a deflection. So there's an electric field, and we'll see that electric field is emanating from the outside of the pail. Now I'm going to touch the pail and watch the leaf on the electrometer. It goes back to no charge. Okay, now there's no charge, we'll see means there's no field emanating from the pail, but now I'm going to remove the charged PVC rod. And you see that now there's a charge registering on the gold leaf. So again, there must be an electric field emanating from the pail. Okay, so here is our starting point showing our pail, and our pail is uncharged, so at this point there's no deflection of the gold leaf on the electrometer when it's in the vicinity of the pail. So when the charged PVC rod is placed inside the pail, the electrons on the PVC rod will repel the electrons in the conducting pail so that they will be now on the outer surface of the pail, and the inner surface of the pail will be positively charged. And so that is why at this point we saw that there was a deflection in the gold leaf of the electroscope, because now there was an electric field emanating from the outside of the pail. Okay, now if I come in and ground the outside of the pail, such as by touching it here, now there's a low resistance path to ground for those electrons to go. And so those electrons will disappear to ground, and we'll see then that there's no longer an electric field emanating from the pail, and as we saw in the experiment, now there is no deflection of the gold leaf on the electrometer. Okay, so now we have a net positive charge on our pail, and the electric flux lines are going from the positive charge on the pail to the negative charges on the PVC rod. Now if we pull out the PVC rod, then what will happen is those positive charges will redistribute and be on the outside of the pail, and the electric field lines will now emanate from the outside of the pail. And as we saw in the experiment, when we pulled the rod out, then we sensed that now there was an external electric field emanating from the pail because of the deflection of the gold leaf on the gold leaf electrometer. Let's go back to this point where we first put the negatively charged rod inside the pail. And what we saw is that if we ground the outside of the pail, we'd lose the charge that was on the outside of the pail. And Michael Faraday made some careful measurements and showed that the amount of charge that was removed from the pail this way was exactly equal to the amount of charge that was inside the container. So he thought of the charge on the inside of the container as displacing charge from the container, and so that's why he would refer to this as a displacement flux that was emanating from the charges inside the pail. Now let's think about what would happen if I start to lower a conducting charge sphere into our neutral pail until it actually touches, say, the bottom of the pail. Okay, so let's assume the sphere is charged positively, so we will have electric field lines that will emanate from the positive charge and terminate on negative charge on the inside surface of the pail. And then of course the pail is neutral, so you'll have to have an equal amount of positive charge on the outer surface of the pail where the electric flux densities re-emanate. And as I lower the sphere, and hence the positive charge, the negative charge is also lowering along the inside. Now here's a point where I've gotten very close to the bottom. So now the positive charges are concentrated on the bottom of the conducting sphere and on the this surface of the pail. And if I actually bring them into contact, since they're both conducting, what will happen is the charges will redistribute so that both the sphere and the inside of the pail will be neutral, but we are still left with a positive charge on the outer wall of the pail where the electric flux density lines emanate. I've charged this metal sphere so you can see when I bring it near the electroscope the deflection of the gold leaf. So now when I lower it into the pail, you'll see the gold leaf deflect, signifying there's now a charge on the outside of the pail. And once I have it in the pail, if I move it further down, there's not a change in the deflection, but if I bring it out, the deflection goes away. Now I'm going to lower it in until I touch the pail. So now there's no charge on the sphere when I bring it out, and you can see the deflection remains on the electroscope as that charge is now on the outer surface of the pail.